All right, let's look at 4.3, techniques of integration for definite integrals. Our goal is to learn to apply the technique of integration of chapter 3 to integrals with bounds, to definite integrals. So in the first section, we'll look at substitution for definite integrals. I have a mantra. Oh, there's an N missing. I have a mantra. If you change your variable, then you must change your bounds. All right, so let's see what this means for substitution. Substitution rule with definite integrals. Let u be a differential function. Then the integral of f of g of x, g prime of x, we saw that that was f of u du, right? That's what we did in the entire substitution section. Now, the only thing we have to know is what are the bounds? Are they still a and b? Well, no. A and b were the values for x, so x went from a to b. While x goes from a to b, u takes on different values. It will actually go from g of a to g of b. All right, so let's try to, well, actually, let me write a bit more. So that means when x is a, when x is equal to a, well, u will not be a, u will be g of a because u is g of x. And if x is b, then u will be g of b. That's why the bounds here have g applied to them, because now they're the values of u. Since u is your variable, those bounds need to be the value of u. All right, so let's try an example. Example 4.3.1, we'll look at two different substitution, and then we'll do more in the worksheet. Let's say I have the integral from 2 to 5 of sine of x squared x dx. Then the substitution I should take is x squared, since that's inside a sine. The derivative will be 2x, which I sort of have. I have the x, and so what I'll get is x dx, which is what I have, will be 1/2 du. All right, so this would be the integral of sine of u, 1/2 du. All right, so that's the substitution that we usually do. And now I have to worry about 2 and I have to worry about 5. All right, so let's write them here. As x is 5, u, which is x squared, will be 25. All right, so the top bound is 25. And as x is 2, u is x squared is 4. All right, so this is the integral that I have to compute. I can take the 1/2 outside. Now I have to take an antiderivative for u. That's minus cos of u. I'm going to plug in 4. I'm going to plug in 25. So I get minus 1/2 cosine of 25 minus 1/2 cosine of 4. All right, and if I want to write it in a more simple way, I get cosine of 4 minus cosine of 25 over 2. I was able to plug in these values directly in u. I didn't have to go back to x because these are the values for u. I've changed them. These are the values for x. These are the values for u, so I plug them into u directly. So there is one step of the usual substitution that we do not take. We don't need to go back to x here. All right, let's try this one here. All right, I have log of x inside. Du will be 1 over x dx. I have the du here, so this would be cosine squared of u du. Let me apply the change to the bounds directly. You don't have to do it separately. So we're told to apply the function to the bounds. So here I'm going to apply log to them. I'll get log of 1 and log of e. So my bounds, if you evaluate them, are 0 and 1. All right, and at this point, I have to evaluate the integral of cosine squared. We've seen how to do it in chapter 3. We used the double angle type in identity. All right, so 1 plus cosine 2u over 2. So I'm getting u over 2 plus, and then the integral of cosine is sine. I have that extra 2. We've learned that that means you divide by the 2 from 0 to 1. And so I get 1/2 plus sine of 2 on 4 minus 0 over 2 plus sine of 0 on 4. Don't forget to plug in both. You plug in 1 and you plug in 0. Often for 0 you get 0, but not always. There are a bunch of functions that don't give you the 0, but in this case you do get 0. And so you'll get 1/2 plus sine of 2 over 4. All right, so here's the note that I was talking to you about. For definite integrals, you do not need to go back to x. At the end of the problem, you simply plug the bounds for u into u.